On July 1st, 2025, telescopes in Chile working with the Atlas survey picked up a faint, fast-moving object. At last, the Asteroid Terrestrial-impact last alert system flagged an orbit with eccentricity well above 1, the signature of an object not gravitationally bound to the Sun. At first glance, it seemed like countless other icy fragments drifting through space.
A nuclear-powered spacecraft sent by aliens, and he says an image from the Hubble telescope.
But when astronomers ran the orbit, the answer was startling. This was not a native of our solar system. It was on a hyperbolic path, a one-way trajectory proving it had come from far beyond. They named it 3I/ATLAS, the third confirmed interstellar object ever detected.
Well, it will be moving relative to Earth
At over 200,000 kilometers per hour, it's moving so quickly that the Sun cannot capture it. This traveler is just passing through. Yet what should have been a routine scientific curiosity has instead turned into a puzzle that unsettles even seasoned experts. Because while some of its behavior looks comfortably familiar, other details are strange enough to raise the possibility that it may not be natural at all. Telescopes turned quickly to study it. The Hubble Space Telescope, Gemini South in Chile, and NASA's infrared facilities all tracked the speck of light as it crept across the sky. As the weeks passed, it began to change.
Catching the attention of some of the nation's most renowned scientists, raising the theory this may actually be a piece of alien technology.
By late August, Gemini South captured a spectacular image. A growing tail stretching from a bright core, proof that the object was releasing dust and ice as the sun's warmth touched its surface. To most astronomers, this looked like exactly what a comet should do. The coma, the jets, the ejection of material into space, all of it was consistent with natural outgassing. NASA even emphasized that 3I/ATLAS posed no threat to Earth. At its closest, it will still remain nearly twice the Earth-Sun distance away, about 1.8 astronomical units, which is roughly 270 million kilometers. Safe by any measure. Yet Hubble's images also reveal an unusually steep brightness profile, steeper than typical solar system comets, a clue that reopened the size debate. But dig deeper, and the mysteries appear. Some of the chemistry emerging from spectral analysis doesn't match what scientists usually expect. Early results hint that 3I/ATLAS may contain an unusually high ratio of carbon dioxide compared to water ice, suggesting it formed in an environment unlike our own, perhaps colder, harsher, or irradiated differently. Spectra also point to water ice mixed with carbonaceous minerals and silicates, with hints that the water may be chemically pristine, lacking the heavier isotopic fingerprints common in many solar system comets. A few researchers even speculate it could originate from the Milky Way's thick disk, a population of ancient stars much older than our Sun. If true, then this visitor is not only from another star system, but from a region of the galaxy unimaginably far and ancient. A time capsule billions of years old, carrying material from stellar nurseries long vanished.
However, I wrote a paper last week that actually a spacecraft that is orbiting Jupiter, it's called Juno.
Drifting untouched until now into our field of view.
Is actually a nuclear-powered space sent by aliens.
And then there is its orbit. The trajectory of 3I/ATLAS is retrograde, moving against the flow of the planets. Yet it lies within just a few degrees of the ecliptic plane, the thin slice of space where Earth, Mars, and the others circle the Sun about 5 degrees from that plane. By chance alone, the odds of this alignment are tiny, on the order of 0.2%. But that alignment also means a series of close planetary approaches. On October 3rd, the object will sweep within about 29 million kilometers of Mars. Later, it will pass close to Jupiter, roughly 33 million kilometers. And at the end of October, as it makes its closest approach to the Sun at about 1.35 astronomical units on October 29th, it will do so while Earth is on the far side of the Sun. At the very moment astronomers most want to study it, the object will be hidden behind the blinding glare of our star. Combine those alignments and encounters, and the odds of a random interstellar object hitting all three shrink to about 0.005%, roughly 1 in 20,000. To some, this is an uncanny coincidence. To others, it looks almost strategic. the exact timing one might expect from something designed to avoid observation. That possibility has fueled the most controversial theory of all. Harvard astrophysicist Avi Loeb, who previously argued that the first known interstellar object, Oumuamua, might have been artificial, has raised the idea again. If we assume pure reflection, the observed brightness implies a body nearly 20 kilometers across, gigantic for an interstellar visitor and statistically implausible, perhaps a once in 10,000 years event.
We see that it has a huge coma, 1,000 kilometers in diameter.
So what explains the brightness? Loeb suggests that perhaps it is not entirely reflected sunlight. Perhaps the object is producing some of its own light, making it appear larger than it really is. If so, it could actually be just a few hundred meters across and possibly powered. That shift isn't cosmetic. It rewrites the probabilities. If you were designing a craft to enter our solar system, Loeb argues, you might even time your maneuver to perihelion while Earth is out of sight, using the sun's glare to shield your operations. He frames it as a reverse solar Oberth maneuver, a high-thrust braking strategy that could allow a craft to shed speed near the sun and potentially remain in the solar system instead of sailing straight through. It is speculation, but speculation grounded in oddly coincidental details that make many pause. Most astronomers reject this interpretation. They point to the dust production rates, between 6 and 60 kilograms per second, as entirely normal for a comet. The tail length, the coma size, the velocities of ejected particles all fit within known cometary physics. And the absence so far of cyanogen, Cn, or diatomic carbon, C2, isn't surprising at around 4 astronomical units. Most comets don't vent strong gas signatures until they're closer to the sun. To sustain an artificial illumination for millions of years of travel would require enormous energy on the order of 10 gigawatts, far beyond anything we can conceive of powering a small probe. To them, the responsible explanation is that this is a comet unusual in composition, valuable for study, but natural. Yet the fact remains that even the natural explanation forces us to confront the unknown. If this is a comet, it is one that challenges our understanding of how comets form.
Barely inside the orbit of Mars, and then it's going to keep going on its way out of the solar system. Instead, around the nucleus, there is some coma, which is an indication that this object is in fact a comet.
Chemistry hints at planetary systems shaped differently from our own. Its trajectory reminds us that interstellar objects can arrive on paths that bring them startlingly close to our planets, and its rarity makes every observation precious. The truth is, we have no baseline for what is normal. With only 2 interstellar objects studied before Oumuamua and Borisov, each new discovery feels less like confirmation and more like a reminder that the universe is full of surprises. The coming months will be critical. In early October, as 3I/ATLAS passes near Mars, there are discussions of using instruments aboard orbiters like the Mars Reconnaissance Orbiter to try to capture high-resolution images, not just a faint streak on a telescope sensor, but the first close-up of an interstellar object's surface. Around perihelion, Earth-based telescopes won't see it at all. The sun's glare blocks the view during the most telling phase. In late October, the James Webb Space Telescope will continue to track its infrared emissions, looking for signs of heat, jets, or unusual luminosity. By early December, during its safe, distant Earth flyby and re-emergence from solar glare, ground-based telescopes will have another chance to study it before it fades back into the dark. Each observation is precious, because once this object is gone, it will never return. And this is only the beginning. The Vera C. Rubin Observatory in Chile has begun operations and is expected to find dozens of interstellar objects like this every year. With a larger sample, scientists will finally be able to determine whether visitors like 3I/ATLAS are rare anomalies or common messengers. They will study whether their chemistries reveal the full diversity of planetary systems across the galaxy. They will test whether trajectories like this one, suspiciously aligned with the planetary plane, are common accidents or rare outliers. And if any future visitor shows evidence of being powered, the implications will shake the world. So why do scientists fear what 3I/ATLAS really is? Because the truth, no matter which way it falls, is profound. If it is natural, it means the universe is more diverse and unpredictable than we imagined. And our solar system is just one peculiar recipe among countless others. It means our assumptions about planet formation, comet chemistry, and galactic history are incomplete. If it is artificial, then we are not alone, and the most important discovery in human history has arrived quietly, disguised as a comet, slipping past us with only a fleeting window to catch it. Either way, 3I/ATLAS forces us to confront how little we know and how much we still have to learn. A faint smudge of light, drifting against the backdrop of stars, has become a mirror reflecting our own uncertainty back at us. It challenges our models, it teases our imagination, and it whispers that the cosmos still holds secrets that could redefine everything we think we know about our place in it. And as it arcs away, tail streaming, fading back into the dark between the stars, we are left with the same mix of fear and wonder that has always defined our gaze upward. Fear, because it shows us the limits of our knowledge. Wonder, because it proves the universe still holds mysteries vast enough to shake us. 3I/AATLAS is more than a comet, more than an interstellar visitor. It is a reminder that the story of the cosmos is not finished, and that perhaps, just perhaps, someone else is writing chapters we have yet to read.